Hi, and welcome to section 2.3. We're talking about sample surveys in the real world. Question that we're going to answer: how do errors affect the results of surveys? And what we'll get to is we can identify errors in survey methodology. So take a quick think about for you. Comment on the potential bias of the following design. 300 random Wright County adults were called to participate in a survey with 140 responding. With the Minnesota budget surplus reaching billions of dollars, do you agree or disagree with the surplus that the surplus should not be spent on state infrastructure as opposed to giving the money back to the people? You're looking at that question, you're probably thinking, huh? Okay, it is very wordy. Now imagine hearing that over the phone. So a confusing question is going to lead to some issues with this. Now, as far as getting our people to respond, we use randomness. 140 is not a lot, but we're using randomness, so that's good. We just have a bad question. It's confusing. And if you go and you look at it, do you agree or disagree that this should not be spent on that as opposed to that? We kind of got a little double negative going on with that. So it would really take, it would really take a little bit of explaining going on with that. And if you don't have this in front of you to read and you just heard that question over the phone, that would be quite confusing. And I created that question to purposely be confusing, to prove a point with that. So confusing questions can cause some bias in that. So the sampling frame. So when we're looking at sampling and the act of getting the sample, the sampling frame is where we get the individuals. So we have some population. So let's just say we have U.S. adults, and we are going to do a phone survey. U.S. adults for a phone survey. All right, the list of individuals from which the sample is drawn. Now, here's our population. We're going to say that this is U.S. adults. U.S. adults. Now, I want you to think about this. If we're doing a phone survey, our U.S. adults, what list of individuals are we getting? Well, we're getting people with phones. They have to have a phone number in order to be on this list. So our population is automatically going to leave off some proportion or some percentage of the population. Our sampling frame in this situation would be U.S. adults with a phone. Adults with a phone. And then we're going to get our sample from that. So while we say our population is U.S. adults, if it's a phone survey, well, the sample frame is going to be U.S. adults with a phone. So we're leaving out some proportion there. We use the observed sample characteristic to estimate population characters. Sampling errors that can occur, errors that are caused by the act of taking a sample, and this would be a situation here where our sampling frame, we're going to leave some people out. So these errors cause the sample results to be different than the results of a census. So this is going to lead to some of those numbers being a little bit different. And if I could draw your attention over here to picture number 1, you look at if we've got this jar with green and red, and you look and it looks pretty similar. If we blindly reached in and grabbed mounds full, and you look over at question 2 or at picture 2 over here, and you see that, well, we got this. That could happen. We could do a survey of Buffalo High School students. Let's just say we want to do a random sample of 50 students, and Buffalo High School, we have 1,900 students in the school. Well, it could just by chance land with 50 ninth grade females. And now, is 50 ninth grade females representative of the entire Buffalo High School? Are we going to get good information from that? Probably not. But the reality is that it could happen. It's sampling. It's errors that come from the act of taking a sample. We could use perfect sampling techniques, but it's just by chance we got a sample of 50 ninth grade females. It's chance. That's how it happens. Random sampling error. This right here gets the benefit of the margin of error. So the deviation between the sample statistic and the population parameter caused by the chance in selecting the random samples. So this is where we get our 95% confidence interval. So 95% of the time, 95% of the samples we grab, we can say that we're going to grab the parameter within that margin of error. So we get the benefit of the margin of error from random samples that are good. So the margin of error in a confidence statement includes only random sampling error. So if you look at this and you say, okay, you've got 1,000 people that you surveyed, and that leads you to, I believe it was 3.2% margin of error, which is a nice margin of error, 3.2%. But if you have a bad question, if you have other kinds of issues going on with that, like you're using a convenient sampler or voluntary response sample, what you're going to find is that you don't get the benefit of the margin of error if you're not using a random sampling. So you don't get it in voluntary response. And you remember that's where they respond to some general appeal. We don't get the margin of error in that because that is a non-random sample. And if we use bad questions, if we have a misleading question, that does not get the benefit of the margin of error. Only if we use good statistical techniques, we use good random sampling, and we have good unbiased questions, do we get the benefit of that margin of error. Under coverage, this occurs when some groups in the population are left out of the process of choosing a sample. And I have the phone banks over here because who's left out in a phone survey? People without phones. You go back to the sampling frame up here. We've got the U.S. adults here, and I shouldn't have deleted that. We've got the U.S. adults here as our population. We're leaving out people. If you look, this rectangle here is smaller down here. Now, not proportionally, but it's still going to be smaller. Our U.S. adults with a phone, you need to have a phone to take the phone survey. So when you go here and you look under coverage, who are we leaving out? People without phones. They're not going to be part of the survey. So that group in the population is left out of the process of choosing a sample. Non-sampling errors, these are errors that are not related to the act of selecting a sample. We've got processing errors, response errors, and non-response errors. Processing errors, this is going to be the mechanical mistakes that happen. So whether it's arithmetic, entering information wrong, if you're gathering some information and it's 10.3 and you accidentally put in a 103 when you're typing in your data. So this is processing errors, a process of putting the data in. Or if somebody's taking a survey and says, agree, and you accidentally select disagree, that would be a processing error. Response errors, this is when a subject gives an incorrect response, whether it's a lie, whether they remember incorrectly or have a faulty memory on it, or they misunderstand the question. So if you were to go up and you say, have you ever, whatever, insert illegal activity here, this might lead to, well, we might lie about what we're saying. So that might lead to some sort of lie if we're asking. Now, there are ways to get that information without having oneself be known who it is, so it could remain anonymous. But if you got the old clipboard out and you're asking people, hey, have you ever done this illegal activity? Well, you're probably going to get some sort of response error with that when the subject is going to give an incorrect response. Question like, how many glasses of milk did you drink last year? Something like that. Well, you might remember incorrectly or have some sort of faulty memory. You could estimate, but once again, that's not really something that you think about. And then the last one, misunderstanding the question. Do you agree or disagree with the ratification of the 26th Amendment? So maybe you don't totally understand the question. You need to know, what does ratification mean? Do you know what the 26th Amendment means right off hand, or what the 26th Amendment was right off hand? So you might get some people say, oh, I totally disagreed with it, with mistaking it for another amendment or not knowing what ratification meant. So you might get some of that misunderstanding with the question there. Or go back to the warm-up there where we talked about the surplus question. You might not understand the question. Non-response error, this is failure to obtain data from an individual selected for a sample. So I'm sure a lot of you get phone calls, especially this time of year and this time in the election cycle, that want to get some information from you. And hey, do you have time to take a survey? Nope. Or you just don't answer the phone. Usually because contacts or subjects cannot be contacted or refuse to cooperate. You've got your door-to-door political pollsters that are walking around. Read the comic there, but Your non-response is failure to obtain data from an individual selected for the sample. So they get selected, but you don't get the information from them. The margin of error only covers random sampling error. We touched on this a little bit before. Undercoverage, non-response, and other practical difficulties can cause large bias that is not covered by the margin of error. So if you have a bad question or if you have bad sampling or other things going on there, the margin of error only covers random sampling error. Question wording can have a big effect on it. You know, if we're trying to coax an answer, hey, this is the correct answer with this, we can word it in a way. Exact wording of a question can have a large effect on the results of a survey. One word can have a big effect on it. It can be complicated or confusing questions. It could be loaded or have double negatives or double meanings. It could be a leading question or it could be a sensitive question. So with question wording, you can see here we've got this orange person trying to coax this, I don't know what color that is, dark orange person. We're trying to coax the correct answer out of that person there by wording the question in a certain way or having certain surveyor characteristics that we have there. Dealing with non-sampling errors, you substitute other households in the same neighborhood. So say you're doing a survey where you have addresses. That's where you're getting your survey list is from addresses. So public information, you go in and you can't get somebody to answer their door, so you go to another house in the same neighborhood. Randomly select another house in the same neighborhood. You could weight responses, so use the weighting to get results as if the sample matched the population. So if for instance, let's just say that Buffalo High School is 25% ninth graders, 29% 10th graders, 11 has 26%, and 12 has 20%. I just made those numbers up, so that's probably not true. But what we could do is we could get the responses from the ninth graders, and then we have some factor that we can have them worth 25% of the weight, even though it's not 25% of the people that were surveyed or sampled. Likewise with 10th graders, we could weight them at 29%, so as if the sample had 29% 10th graders. So we can sample based on some other things, or we can weight based on other things. Stratified sample, this is going to force the hand of this weight, as you'll see. So step one, what a stratified sample is, you divide the sampling frame into distinct groups of individual called strata. These are special groups within strata or individuals to resemble one another. So if we were to look at this and say, okay, let's do the high school. Well, my strata, an easy strata that we could have is 9th grade, 10th grade, 11th grade, and 12th grade. And we could force the weight of that. If I say I wanted to sample 100 people, I could do 25 ninth graders. I could do 29 10th graders. I could do 26, or however you want to do it. So you could force the weight. You can also force inclusion of certain groups by doing that. So we can say, instead of weighting it by percentage, you could also say ninth graders. I want to get 50 ninth graders. I want to get 50 10th graders. I want to get 50 11th graders. And I want to get 50 12th graders. So what you're going to do within those is you're going to split them up and you're going to take a separate SRS within the stratum to make the complete sample. So if you look at this is a good diagram here. We've got our entire population here. What we're going to do is you have triangles, circles, and squares. We're going to put all the triangles in one. So, these could be your ninth graders, so to speak. And then what we're going to do is we're going to random sample from there. So you have groups of your triangles. We're going to grab a random sample of triangles. We've got all our circles together. We're going to get a random sample of circles. We're going to get a random sample of squares. That way you have representation from all groups within your population, so you can force the hand of that instead of relying on a random sample including them, a simple random sample including those populations. You can say, hey, I know that I want to get 9th grade, 10th grade, 11th grade, and 12th grade, so I'm going to do a stratified random sample. I'm going to add a step in there that ensures that I'm going to get equal representation or weighted representation, as we kind of talked up there on this survey. A probability sample is going to be a sample chosen by chance, so there's going to include chance. Know what samples could possibly be chosen. You've got SRS stratified samples, so random sampling would be your SRS stratified sampling. Cluster sampling would also be another one. So if I wanted to get some information from students at Buffalo High School, an example of cluster sampling would be selecting a random teacher, say a random first block teacher, and then going in and sampling those students. So that would be a cluster of students. Or if you're in Buffalo, you're going to cluster sample. What you'll do is you'll select neighborhoods or areas, and you'll sample everybody within those. So that would be cluster sampling. A non-probability sample does not share the advantage of small bias and margin of error. You do not get to claim the margin of error if you use a non-probability sample. So convenient sampling we talked about, voluntary response sampling we talked about, judgmental sampling. That one's a little bit more complicated, but it's based on professional knowledge of something. We'll kind of gloss over that one. Quota sampling, you're going to sample until you get 25 freshmen and so on. So probability sample is the sample chosen by chance. So simple random sample, stratified random sample, that's where we'll live for now. Before you believe a poll, so this kind of sums up just about everything we've talked about, and I'll have you do a little poll, dig into the fine print of a poll here as a project for tomorrow. But before you believe a poll, what you want to do is you want to find out who carried out the survey, what was the population, how was the sample selected, how large was the sample, what was the response rate, how were the subjects contacted, when was the survey conducted, and what were the exact questions asked. So as you become more and more wise to the ways of statistics, and you see some poll or some headline or some samples that their survey results, and you can look at it and you can say, okay, show me the fine print, show me the methodology that we can go in and we can look at this and see if this is an actual good poll. So it all comes back to what I was talking about in chapter 1 when we talk about scrutinizing information that we get before we believe it. So this is what we're talking about. Ask yourself some of these questions. Look at the fine print. The fine print should be there if it's a good poll, and you should be able to find out all this exact information. So that is sampling in the real world. Sample